Bangladesh was divided in two by this mighty River Jamuna. A journey from east to west involved a ferry crossing which could take hours. Now Bangladeshis can cross the Jamuna in a matter of minutes. This bridge has united the people and the country and their economy in a way they never were before.
My name is Dick Tappin. I was the project director for the Rendell Palmer and Tritton and Nadeco joint venture for the Jamuna Bridge. The government requested that we investigate how to transfer the gas surpluses from the Sylhet fields to the western region of Bangladesh. There was a need to transfer agricultural projects to Dhaka and Chittagong before they perished. It made sense, therefore, to suggest to the government that it would be better to have a bridge that could carry road and rail as well as a gas pipeline. In consequence, the Rendell Palmer and Tritton Nadeco joint venture was appointed to do a full feasibility study, design the bridge and supervise the construction. The river, which is extremely wide and unstable, had not been crossed within the area of Bangladesh in the past and was a considerable engineering challenge. Perhaps I should now recall what I said 20 years ago.
Dick, before you came along and said a bridge could be built here, many engineers over many years have said it is impossible to cross this river with a bridge. Why was it thought to be so difficult to bridge this River Jamuna?
There's two fundamental problems. One is the nature of the ground material, which makes foundations extremely difficult. The river scours to considerable depths, and also it's a seismic area. There are reports in 1885 of the wells fill in with liquefaction of the ground material. So that was the first fundamental problem. The second is the nature of the river itself, which is a braided river.
Braided means it runs in little streams.
It runs in little streams and they vary. If you imagine a girl's long hair and all the sort of plaits interwoven, the river is like that. And between these deep channels and shallower channels there are chars, the local name for islands, and these move every season. The water levels vary by about 8 meters between the seasons, and the river banks vary considerably year to year.
To stabilize this river, it was necessary to build extensive river training works. We found that the most economic way to do that was and the safest way to do that was to get the different channels of the river converged, to converge them between river training guide buns. These were 2.5 kilometers in length, considerable constructions, and were set approximately 5 kilometers apart. The second major problem on the project was the foundations, where the alluvial material is very weak and continues for kilometers. As a result, 3-meter diameter piles were a solution which civil engineers suggested and required the use of the world's largest pile hammer, which had recently been developed for use in the North Sea. The third primary element of the total project was the bridge superstructure, and Steve Harridge will now talk about that element of the work.
At the time when Jamuna Bridge was being designed and built, I was a partner of Tony G and Partners. The successful contractor were the Korean company Hyundai. They in turn retained Tony G to design all the temporary works, the construction engineering calculations, which on a project like this are quite extensive, and principally to design the gantry, which was used to build the bridge. The bridge was built using the balanced cantilever method. So you start off with a pierhead segment sitting on top of a pier, and then you launch the gantry out on top of that newly placed segment, and then build segments out symmetrically either side of the pierhead segment until eventually the back end cantilever meets up with the previous cantilever, which you then join up and then repeat the process all over again, another 47 times. The other essential part of the gantry design was that it should be reliable, because if there was a major breakdown of the machine halfway across a 4.8 metre wide river, the repair of it would have been extremely difficult. I'm glad to say that there were no faults there, they had no maintenance or breakdowns problems at all. The bridge was completed in accordance with the programme and pretty close to the original budget, but there were substantial benefits, as Dick referred to earlier, in the construction of the bridge, but I leave it to Iqbal to describe for himself the benefit to the people of Bangladesh.
Unlike Dick and Steve, who were part of the design and construction of the Jamuna Multi-Purpose Bridge, I have a different perspective. I am of Bengali heritage and I know better than anyone the benefits it's brought to the Bangladeshi community. It might be a cliche to say that bridges connect people, but in this case the Jamuna Bridge is a perfect example of how it connected the eastern side of Bangladesh to the western side of Bangladesh, which is separated by the Jamuna Bridge, which runs approximately north to south, thus dividing the country. Previously, river crossings were heavily reliant on ferries, which often were unsafe, and now the Jamuna Bridge has formed a permanent, all-year-round, safe connection, allowing people to cross safely. And not only that, it's a multi-purpose bridge, and it offers to carry power lines and gas lines and a railway line. Through the ingenuity of civil engineers, the likes of Dick and Steve, a pragmatic solution was created. As the Jamuna Bridge is a perfect balance of form, function and environment. Civil engineering is a challenging profession, but it's very rewarding because it offers a good balance of technical abilities and creating pragmatic solutions which have a long-lasting benefit to humanity. And the best thing about being a civil engineer is once you've done a project, you can stand back and look at what you've built.